Going to solve this problem called linked list cycle. Given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer internally. Pos is used to denote the index of the node that trio's next pointer is connected to. Note that pos is not passed as a parameter. Return true if there is a cycle in the linked list. Otherwise, return false. So this is an example. You can see it have a cycle within the linked list because the minus for this node with the value minus for next pointing isn't null. Instead of null, it is 2. It is the node with 2 value. So you can see it's a cycle. It's a cycle in this linked list. And you can see example 2 can also be a cycle. For example, the node with the value 2's next pointer, the next is not a null, but this value, this node 1. And example 3, you can see there is no cycle in the linked list. It's just one single linked list. Just one value, just hold one element in the linked list. So you need to return false. How to solve this problem? At first, you can just use a hash table and to push every element into the hash table. If you find 3, and then push 3, push 2, put 0, put minus 4, and the false next is 2, and you can see it already in the hash table. So if you find the 2 appear twice, it means it has a cycle in the linked list. You need to return true. But if you if the minus 4 pointing to null, if you use a hash table, and you can see you just jump out the for loop, do one loop, because of this node. This node's next is null. So every element in the hash table just appear once. But I think follow-up can also it using O1 memory, so you can't use hash table. And I use faster slow pointer technique. It means you create 2 pointer, a fast pointer and a slow pointer. The fast pointer move the twice the speed of slow pointer. It is say the fast pointer move 2 steps and a slow pointer just move 1 step. And in the end, when the 2 pointer can encounter, if the two pointer meet together, it means it has a cycle in the linked list. So, but if the fast pointer always move faster than the slow pointer, if the fast pointer is null or the fast pointer's next is null, it means you don't have a circle in the linked list. So this is I use a Java, and at first it's a case. It's a binary case. If we were given a data structure like a data structure like this, and we were given head is the head of the linked list. If the head is null, you need to return false, because we don't have a cycle in linked list, obviously. And at first I initialize two pointer, a slow pointer and a fast pointer. The slow pointer at first just is set to be hide, and the fast pointer is set to be head dot next. And then well, it's a while loop. Well, slow isn't equal to fast, so they can't. But if slow is equal to fast, it means it has a cycle. So you need to return true. And here, if slow isn't equal to fast, you just let the two pointer move. Slow pointer move one step and the fast pointer move two steps. And but if it just has a node in the linked list, so the fast at first it become null, so you will return false, and all fast dot next is equal to null, you also need to return false. So this is the conditional we break out the while loop. But if you put here like this, it will be wrong, because fast, if you just have one node, fast dot next, it will be overflow. So at first you just need to check for fast is null or fast dot next is null, and you jump out of the while loop. Okay, you can see it's accepted. And I think that this class list node has a value like int, and this one is to keep the value of the node, and here is internally to keep where is the next node, so the next to keep the address of the next node.